Hello friends. So today we'll discuss about type 3 problems, that is balancing of several masses in the same plane and related problems of this case. So this is case 3, balancing of several masses in the same plane. So we'll take an example and we'll try to solve this analytically and graphically. So we'll take an example. Three masses m1, m2, m3 with 10, 9 and 16 kg respectively revolve in the same plane with radii 100, 125 and 50 mm respectively. Angular position of these masses are m2, m3 are 60 degrees and 135 degrees from mass 1. Means from mass 1 to mass 2 is 60 degrees, mass 1 to mass 3 is 135 degrees. Determine the position and magnitude of mass m4 at the radius 150 mm to balance the system. So there are three masses here. So we have to introduce mass m4 to balance the system. So first, draw the space diagram. This is called the space diagram. As you can see, since mass 1 is a reference, so mass 2 and mass 3 are 60 and 135 degrees from mass 1. So mass 1 is at 0 degrees. So this is mass 1 at 0 degrees or horizontal. So first draw mass 1 0 degrees or horizontal m1. Show it here. m1 is 10 kg corresponding r1. And next is mass 2. From mass 2 with mass 1 is 60 degrees. So mass 2 is at 60 degrees. So mass 2 is 9 kg r2. And mass 3, so from mass 1 to mass 3 is 135 degrees. So mass 3 is 16 kg with corresponding r3, it is r3. So in order to balance these three masses, we have to introduce one more mass m4, which has some angle. We don't know what is the angle. We have to find this angle. Also we have to find the mass of this m4. But radius is already given. So radius of r4 is already given, that is 150. So just we have to find m4 and theta 4. So after drawing the space diagram, this is called a space diagram, draw the tabular column. So draw a tabular column with mass, radius, force and angle. So draw the mass, write the masses m1 10 kg, m2 9 kg, m3 16 kg given, m4 is unknown, so question mark. And write the radius, corresponding radius, but radius should be are written in meters. So the radius 100, 125, 50. So 100 mm is 0.1 meter, 125 mm is 0.125 meter, just divided by 1000, and 50 mm is divided by 1000, we get 0.05 meters. And radius of this also is, radius of m4 is known, that is 0.150 mm. So therefore it is 0.15 meters. Now calculate the force. To calculate the force, just multiply mass into radius. So m1 into r1, we get force F1. So m1 10 into r1 0.1, we get it is 1. m2 into r2, we get F2. So m2 is 9, r2 is 0.2125, because we get 1.125. Next, m3 16 kg, r3 0.05, we get 0.8 F3. Lastly, the unknown m4 into 0.15 is 0.15 into m4. Keep it as it is. And the corresponding angles, since mass 1 is at 0 degrees horizontal, so mass 1 is 0 degrees, mass 2 is at 60 degrees from m1, and mass 3 is at 135 degrees from m1, and theta 4 is unknown. So this we don't know what is a theta 4. So now we will solve this. First we'll solve this by analytical method, then we'll solve this by graphical method. So first, now an analytical method. So analytical method first. So resolving the centrifugal force of horizontally and vertically. So horizontal FH, m1 r1 cos 0 plus m2 r2 cos alpha plus m3 r3 cos beta. So here we know m1 is 10, r1 is 0.1 cos 0, it is at 0 degrees. M2 is 9, 0.25 cos 6, second mass is at 60 degrees, cos 60 degrees. M3 16, R3 0.05 cos beta, the third mass is at 135 degrees, so beta is 135. So multiplying this, we have 1 plus 0.562 plus this. So adding all these three, we have 0.9968 FH is 0.9968. Similarly, vertical force FV, M1 R1 sin theta sin 0, M2 R2 sin alpha, M3 R3 sin beta. So M1 R1 is 10 sin 0, M2 R2 9 10 0.125 sin 60, M3 R3 16 0.05 into sin 135. So simplifying, we have 0 plus this. Setting this 3, we have therefore FV equals to 1.5398. Now resultant unbalanced force is square root of Fs square plus Fv square. So square root of 9968 the whole square plus 168 plus square root of plus 1.5398 the whole square. So squaring, adding and square root of this, we have 1.8328. So for balancing the fourth mass M4, R4 should be equal to this. So M4 equals to, so R4 is already 150 or 0.15 equals to 1.832428. So therefore, simplifying, we have M4 equals to 12.22 kgs. And so the angle is theta is 10 inverse of Fv by Fh. So 10 inverse of 1.53 upon 0.0628 is equals to 37 degrees. So this was the analytical method. Now solving by the same problem by graphical method. So for graphical method, so with a given table, to given these three values, we have to draw the force polygon. So for the force polygon, first draw the M1 force value F1. So F1, that is just 1 at 0 degrees. So select a suitable scale. So suitable scale, so here is 10:1, means one unit is 10 centimeter. So 1. So from the point, select a point O, and with 0 degrees or horizontal, draw 10 centimeter line. And draw 1 equals to, so 10, so draw 10 centimeter line. Click. Now from point A with 60 degrees angle, draw a line A to B, that is 1.125 into 10, that is 11.25 centimeters. Draw a line 11.25 centimeters till B. Now from point B, taking the horizontal, draw a horizontal line. With respect to that horizontal, measure 185 degrees and draw line 0.8. So 0.8 into 10 is 8 centimeter. Draw line from B to C at 8 centimeter line. So till here it is unclosed. So now this unclosed means it is unbalanced. So join this with dotted line from C to O. So join this dotted line C to O, and from C, the horizontal, measure this angle, the whole angle. This angle is theta 4, which measures to 237 degrees. And this unknown line is the unknown part 0.15 M4. So measure this line OC into scale into 0.15 M4. So this line is 18.4 centimeters. Now reverse scale, it was 10 by 1, now it is 1 by 10, 0.15 M4. So therefore M4 equals to 12.27 kg and theta 4 is 237 degrees. So this was about the graphical method. So once again, so 3 masses M1, M2 and 3, 10, 9, 16 kg. The radius 100, 125, 50. Angular positions M2, M3 from M1, 16, 135 degrees. So draw the phase diagram. So M1 is at 0 degrees, reference M1. M2 is at 60 degrees, so just M2, and M3 is at 135 degrees, so draw M3. And M4, we don't know where it is, so we'll find this M4 but radius R4 is given already 150. Draw a tabular column. Show the masses M1, M2, M3, M4 is unknown. R1, R2, R3, R4. Multiply these two to get the force M1, R1, M2, R2, M3, R3, M4, R4. So 1, 1.25, 0.8, 1.14, M4. Show the angles. M1 is at 0 degrees, M2 is at 60, M3 has 135, theta 4 is unknown. Then solve it analytical method using formula, resolving into a horizontal and vertical forces. Horizontal FH, M1 R1 cos 0, M2 R2 cos T alpha, M3 R3 cos beta. Similarly, resolving into vertical, M1 R1 sin 0, M2 R2 sin alpha, M3 R3 sin beta, and so goes on for multiple masses. Now find FH and FV. Find the resultant unbalanced force by the formula square root of Fs square plus Fv square. So find the unbalanced force. For balancing, the fourth mass M4 into R4 should be equal to this unbalanced force. So M4 is unknown, R4 is known, so we get M4, the kgs. So theta is tan inverse of Fv by Fh, so we get the theta also, that is 237 degrees. And by graphical method, so for graphical method, draw these three lines. Draw. So force F1, F2, F3, F4 is unknown. So first to draw a line of value force 1. Take a scale of 10. So 1 into 10 is 10 centimeter. So draw O to A 10 centimeter, 0 degrees. From point A at 60 degrees, draw 1.125 into 10, that is 11.25 centimeters at 60 degrees. From point B, we do horizontal at 135 degrees, draw 0.8 into 10, that is 8 centimeter from B to C. Now close for the C to O with a dotted line. Measure this angle is theta 4, that is 237, and measure this line OC into scale into 0.15 for M4. So OC scale is 18.4 centimeters. Now scale, reverse scale is, so earlier it was 10 by 1, now it should be 1 by 10, 0.14 M4. M4 is 12.27 kg. Theta 4 is 237 degrees from the font.